মানে কখন যে বন্ধ হয়ে গেছে সেটা আমি নিজেও বুঝতে পারছি না। তো আজকের আমি মনে করছিলাম যে শেষের দিকে মনে হয় বন্ধ হয়েছে, রেকর্ডিংটাও বন্ধ হয়ে গেছে আর নেটটাও চলে গেছে। তো ওদের কাছে আজকে বলার পরে বলে যে স্যার একবার শুরু থেকেই বলেন, মানে শুরু থেকেই ওরা বুঝতে মানে শোনেনি। তো এখন যদি প্যারালালি না যায় তাহলে একটু সমস্যা, আরো একটু সমস্যা হয়ে যায়। যদি দুইটা সেকশন যদি একই সাথে না গেলে তাহলে তোমার মানে হয়তো দেখা যাবে যে কোনো একটা মিসিং হয়ে গেছে কারো, আবার কারো একটু বেশি পড়ানো হয়ে গেছে, কারো কম পড়ানো হয়ে গেছে। কোশ্চেন করার সময় তো আর ওইগুলা মাথায় থাকবে না, তখন হয়তো ফুল লেকচার ফুল সিলেবাসই মাথায় থাকে। তো সেই জন্য আজকে তোমাদের অনেকটা রিপিট করবো, শেষে দুই একটা প্রবলেম করানোর চেষ্টা, মানে এক্সট্রা প্রবলেম করানোর চেষ্টা করবো, ঠিক আছে? আর তোমরা ট্রাই করবা যে এই ইয়াগুলোকে তোমরা জমা করে রাখবা না, যেহেতু অনলাইনের ক্লাস। তোমরা নিজেরা কি নোট টোট করো নাকি, নাকি চিন্তা করো যে না এটা তো ভিডিও তো অনলাইনে পেয়ে যাবো সুতরাং আর চিন্তা নাই? এই এই চিন্তা থেকে করলে তোমাদের ক্ষতি। একটু নিজেরা ইয়া করবা, যদিও অবশ্য ইসে চোখ রাখা তোমার যদি কেউ মোবাইল থেকে দেখো তাহলে তো তার জন্য আরো কষ্ট। মোবাইলে চোখ রাখা আবার লেখা, এটা একটু কষ্টকর কাজ। তারপরেও যতটুকু পারো অ্যাটলিস্ট মানে যে কি পয়েন্টগুলো যেটা তোমার জন্য ইয়া হবে, মানে কি পয়েন্ট তো আসলে ম্যান টু ম্যান ভেরি করে তুমি নিজেই আইডেন্টিফাই করবা যে কোন জিনিসটা আমি একটু হলে লিখে রাখলে ফিউচারে তোমার কারণ এই পরীক্ষা যে কবে হবে তার কিন্তু কোনো গ্যারান্টি নেই। হয়তো তোমাদের এই জানুয়ারি মনে হয় এটা লাস্ট ক্লাস, তাই না? জানুয়ারির পরে তোমাদের নেক্সট সেমিস্টারের ক্লাস শুরু হবে। তো এরপর আবার ওই সেমিস্টার শুরু হয়ে গেলে এটা তোমার কিন্তু ইয়া হয়ে থাকবে, জমা হয়ে থাকবে, তখন আবারও ভুলে যাবা। তো সেই জন্য যদি ইয়া করে রাখো, একটু মানে সংক্ষিপ্ত আকারেও যদি নোট করে রাখো ক্রিটিক্যাল পয়েন্টগুলো, তাহলে মনে হয় তোমাদের জন্য একটু বেটার হবে। পরবর্তীতে যখন পরীক্ষার সময় বুঝতে একটু সুবিধা হবে। আর একজন স্টুডেন্ট আমাকে মেইল করছে, দুইটা প্রবলেম করতে পারে না। একটা নূরে ইয়াজদানি, আসো নাকি তুমি?
জি স্যার।
আচ্ছা, গুড, থ্যাংক ইউ। তুমি তো মোটামুটি ভালো দেখা আছে, নিয়মিত মনে হয় লেকচার নোটগুলো করতেছো। যাই তুমি একটা কাজ করবা, তুমি যেটা করছো ওটা হচ্ছে বেসিক্যালি ইনডিটারমিনেট স্ট্রাকচার। তোমরা তো এখনো মনে হয় ডিটারমিনেট ইনডিটারমিনেট পড়ো না, করছো নাকি? তোমরা কি ইনডিটারমিনেট স্ট্রাকচার পড়ছো? এরকম টার্মটা শুনছো কখনো? আচ্ছা, শোনো না, এই দুইটা টার্ম আছে, একটা ডিটারমিনেট আর একটা ইনডিটারমিনেট। মানে ডিটারমিনেট আমাদের যে ইকুইলিব্রিয়াম ইকুয়েশন আছে, ইকুইলিব্রিয়াম ইকুয়েশন বেসিক্যালি সামেশন অফ এফ এক্স, সামেশন অফ এফ ওয়াই, সামেশন মোমেন্ট অ্যাবাউট এনি পয়েন্ট। এটাই হচ্ছে ইকুইলিব্রিয়াম ইকুয়েশন ফর 2D প্রবলেম। আমরা দুইটা প্রবলেম হয় তো 2D 3D, রিয়েল স্ট্রাকচার হচ্ছে সবগুলো 3D, এক্স ওয়াই জেড তিন ডিরেকশনে স্ট্রাকচারটা আছে। আর আইডিয়ালাইজ স্ট্রাকচার হচ্ছে 2D, মানে এক্স আর ওয়াই জেড ডিরেকশন থেকে আমরা ইমাজিন করি না। তো 2D প্রবলেমে আমরা তিনটা ইকুইলিব্রিয়াম কন্ডিশন ইউজ করি, সামেশন অফ এফ এক্স, সামেশন অফ এফ ওয়াই, সামেশন অফ মোমেন্ট অ্যাবাউট এনি পয়েন্ট। এই তিনটে ইকুইলিব্রিয়াম ইকুয়েশন অ্যাপ্লাই করে যদি তুমি প্রবলেম সলভ করতে পারো, মানে প্রবলেম মিন্স ইউ ক্যান ডিটারমাইন অল রিঅ্যাকশনস ইন্টারনাল ফোর্স, দ্যাট ইজ ডিটারমিনেট স্ট্রাকচার। And if you are unable to solve all or to find all reactions using these equilibrium conditions, equilibrium condition is fx fy moment, that is known as indeterminate structure. Indeterminate, that means you cannot determine everything. That's why it is indeterminate, and determinate means you can determine everything. Okay. স্ক্রিন, হ্যাঁ স্ক্রিন তো দেখা যায়, কি জানি একজন বলল, আমি এখন স্ক্রিন শেয়ার করিনি, আমি করব। তো সেটা হচ্ছে ইনডিটারমিনেট স্ট্রাকচার। আমি তোমাদের একটা জিনিস একটু দেখাই, যেহেতু আমি রিপিট ক্লাস করব, তোমাদের একটু ওর প্রবলেমটা একটু দেখাই, তাহলে তোমরা রিয়েলাইজ করতে পারবা কি বলছি। আমি না এটা না, এটা দেখা যাচ্ছে না। এনিওয়ে, তো প্রবলেমটাকে নেক্সট মানে এটা আসবে ইনডিটারমিনেট স্ট্রাকচারে কিভাবে টর্শনাল প্রবলেম সলভ করে সেটা আমি আস্তে ধীরে দেখাবো। ঠিক আছে, তো তুমি যেগুলো এখন পর্যন্ত আমি যেগুলো পড়াচ্ছি সেই টাইপের প্রবলেম সিঙ্গার অথবা হিটলারের বই থেকে ইয়ে করো, চেষ্টা করো সলভ করার। ওখানে যদি কোনো প্রবলেম থাকে তাহলে আমাকে একটু বলো, তাহলে আমি নিজে ট্রাই করে দেবো। আমিও তো আসলে মানে একবারে যে ইনস্ট্যান্টলি সব প্রবলেম করতে পারবো হয়তো তাও না, হয়তো আমাকেও মানে করতে পারে, মানে টাইম নেওয়া লাগতে পারে যে প্রবলেমটা কিভাবে সলভ করে। তো আগে আগে বলে একটু সুবিধা হয়, কারণ হঠাৎ করে ক্লাসে যদি বলো যে এই প্রবলেমটা কিভাবে করবো, তাহলে হয় কি মানে আমরা টিচার অর্থ এই না যে আমি আসলে সব পারি সব জানি। হ্যাঁ, যেমন আমরা ডাক্তারের কাছে গেলেই মানে একবারে ডাক্তার মানেই যে সব প্রবলেম সলভ করে দেওয়া, সব অসুখের সলিউশন দিতে পারবো তা না, হয়তো তাকেও চিন্তা করা লাগে যে আচ্ছা এটা কিভাবে মানে এই প্রবলেম এই ইসের অসুখের কি ধরনের এলিমেন্টস দেওয়া যেতে পারে। আমরা তো বেসিক্যালি আমাদের দেশে ডাক্তাররা তো দেয় ওষুধের নাম দেয়, কিন্তু ওয়েস্টার্ন কান্ট্রিতে তোমার কোনো ওষুধের নাম নেই, শুধু এলিমেন্টস বলে যে তুমি এইটা এই এই এলিমেন্টসটা খাওয়া। তারপরে ওটা মানে এক একটা ড্রাগ স্টোরে এক এক ধরনের থাকে। তো তো সেই ধরনের তো আমরা যেটা যেটা বলছিলাম যে তোমার এটা তোমার যেটা বলছিলাম যে আগে একটু জানালে আমার জন্য একটু হয়, না হলে আমি নিজে একটু অকওয়ার্ড সিচুয়েশনে পড়বো, কারণ আমি তোমাদের সামনে যদি না বলতে পারি, এক্সপ্লেন করতে পারি, তোমরাই বলবো যে স্যার কি নিজেই পারে না কিছু না। এনিওয়ে, তো আমি তাহলে আজকের ক্লাসে চলে যাই। নেক্সট মানে লাস্ট ক্লাসটাই একটু হালকা রিপিট করব, তারপরে একটু প্রবলেম সলভ করব যাতে দুইটা সেকশনে প্যারালাল থাকে। ওকে, আচ্ছা তাহলে এখন দেখো আমি ট্রাইং টু share this. Okay, in the last class I discussed how to draw the diagram. How to draw the diagram. Is it clear to everyone? If this part is not clear, so I drew this diagram in the last class. So is it clear to everybody? Basically, I am briefly explain the problem. Actually it is a solid shaft. It is a solid shaft, and one end of the shaft is fixed to a support C at C. C is a fixed support. So, do you know what is fixed support, or what is indicated by fixed support? Can anybody please tell me what is fixed support? We have learned many kinds of support. Hinge support, roller support. Another one is fixed support. Fixed means for any kind of material, any kind of load, applied load. Basically, applied load will be say axial force, shear force, bending moment, torsional force. For different types of loads, the structure may be elongated or shortened. Okay, that means its length may be increased or may be decreased. That is one response. That is known as response. And another response is the structure may be bent. Okay, may be bent. That means it may be deflected downward or it may be deflected upward. That is bent. That is the effect of bending moment. And for torsional force, the structure may be twisted. Twisted, that means the section will be rotated. Twisted means the section will be rotated. Okay, so that is those are the response. That means length may be changed, or the straightness may be changed. That means the straight may be curved. Initially may be straight, but due to applied load it may be curved, and there may be rotation. Okay, so fixed support means at this location there will be no response. Okay, there will be no response. That means there will be no contraction or elongation along in the length. There will be no curvature. or there will be no deflection, there will be no rotation. That is fixed. Fixed means fixed. There is no sense. So one end of the shaft is fixed to CA. That means at this point there will be no rotation, there will be no deflection, there will be no curvature, there will be no elongation, extension or elongation, or that means there will be no shortening or lengthening. So one end is fixed to C, and another end is free, and at free end the shaft is subjected to a concentrated torsional force 800 Newton meter, and in the middle part, middle segment, the length of the segment is 0.5 meter, and in this segment the shaft is subjected to a uniformly distributed torsional force, that is 4 kilonewton meter per meter. Okay, and at another location, that is 0.2 meter away from the support, there is another concentrated torsional force 400 Newton. Wait, I'm again forgetting to record the. Is it recording? Okay, it is recording. Okay, then. Okay, so the strength of the material, allowable strength of the material is 60 MPa. Strength of the material means the maximum capacity of the material. That is strength, maximum capacity. So if we consider the axial force, so how much maximum load can carry the structure before or can carry the material before failure. That is the strength. Okay, that is the strength. But this one is the allowable stress. Allowable stress means sometimes, for an example, a steel rod can carry 500 Newton axial force, tensile force. A steel rod can carry 500 kilonewton tensile force. But to design purpose, we will assume that no, that steel rod will not carry 500 kilonewton until failure. We will assume it is 400. Okay, it is 400. That means we will consider that if the applied axial tensile force is 400 kilonewton, then that rod will be failed. In that case, that 400 is known as allowable axial force. Allowable axial force. Although from the laboratory test, it is a noise is coming from somewhere.
Calculate what will be TA and TC. Okay, calculate what means this.
Excuse me, someone is. Noise is coming from somewhere. I think 14, 18, roll number 14. Noise is coming from you, so mute you. Are you hearing me? Roll number 1801014. Noise is coming from you. Okay, no more. Okay, so actually, so I was explaining what is strength and what is allowable strength. Strength means the maximum capacity until failure, but as the strength of them or the capacity of the material may vary from sample to sample or location to location. That's why we will apply some safety factor. Safety factor means although the laboratory test indicates that this rod can carry 500 kilonewton tensile force, but in the design process, design process, we will assume that if the applied load to that rod exceeds 400 kilonewton, then that rod will be failed. In that case, that 400 kilonewton force is known as allowable tensile stress. Okay, So for design process, we will not exceed the allowable limit. Allowable limit, it may be the allowable limit may be in terms of force or in terms of stress. Okay, that means we will assume that if the applied or if the internal force, and internal force may be it may be stress or it may be total stress or force exceeds the allowable limit, then that structure will be failed. Structure will be failed. So the allowable stress of the material that is used to make this tube is 60 MPa. 60 MPa. That it is shear stress. One thing, please. If I say stress, always you will assume it is shear stress, because we are talking about torsional force. So due to torsional force, only shear stress will be developed. Due to torsional force, only shear stress will be developed. So if I say anytime the stress, then you will understand that that is shear stress. Okay, unless I am not saying that it is shear stress. Always you will assume it is shear stress unless I say it is axial stress. Okay, so stress means shear stress. So the allowable shear stress of the material is 60 MPa. That means if the shear stress at any point in the structure exceeds this value, that means if the shear stress is greater than 60 MPa at anywhere in the structure, then that structure will be failed. That structure will be failed. So to maintain the safety or integrity of the structure, that means to avoid the failure of the structure, we will apply the float to the structure, or we will provide the section of the structure so that the maximum stress at anywhere in the structure will not exceed this value. Okay, so the allowable stress is 60 MPa. Then the diameter of the rod is not given. That we have to determine. We have to determine the diameter. Actually, this diameter means that is the minimum diameter. Okay, so what will be the minimum diameter that will carry or that will resist this applied torsional force? So from the torsional stress equation, the equation of maximum shear stress. Equation of maximum shear stress is indicated expressed by this equation. This is the equation of maximum shear stress due to torsional force. So here T is the torsional force, C is the for circular shaft, C is the diameter. C is the radius of the section, and J is the polar moment of inertia of the section. So from this equation, it is clear that the value of maximum stress depends on the value of maximum torsional force. If the cross section of the shaft is circular, in that case C will be constant. That means the radius of the section, and J is the polar moment of inertia. So for any specific section, these two terms are constant. Therefore, the maximum shear stress depends on the maximum torsional stress. So in this equation, this torsional force is the internal torsional force. That means due to if any structure is subjected to any torsional force, then torsional force will be developed in the structure, that is known as internal torsional force. So this T indicates the internal torsional, not the applied torsional. Okay, so we have to determine the diameter. So according to this according to the previous equation, we have to we have to check that the maximum shear stress in this shaft will not exceed this limiting value. Will not exceed this limiting value of 60 MPa. Limiting value of 60 MPa. So we have to determine the maximum shear stress, the location of maximum shear stress. So from that equation, we have seen that the equation of maximum shear stress depends on the value of maximum internal torque. So we have to now find out where is the maximum resultant internal torque, and to determine it, we have to see the variation of internal torque along the length of the shaft. We have to see the variation of resultant internal torque along the length of the shaft, and from that variation we can figure out what will be the maximum internal torque, and that is indicated by this diagram. That is the torsional force diagram. So this diagram indicates the value of resultant internal torque at different location. So to draw this diagram, we have to start from one end of the structure. We can start from C, or we can start from here. We have to start from one end of the structure. We will start from here, then we will go towards the support. Then actually we will cover some length. And then that length is indicated by this axis. And then if we go along this line, then we will face different internal torque, and that torque will be represented by this represented along this axis. So this axis indicates the internal torque, and that axis indicates the length of the shaft, or the location of the shaft from one end. So assume at this point the length is 0, so it is 0. So if we move from here to here, then first we will face this internal torque. Then in this segment there is no additional applied torque, and if we cross this point, then we will face this applied uniformly distributed torque. And then if we cross this point, and then in this zone there is no additional applied torque, and if we reach this point, then we will face again this concentrated applied torque, and in this zone there is no applied torque. So first of all, if we start from here, and if we just reach this point, then this is will face this applied torque, and then according to thumb rule, this torque is positive torque. This torque is a positive torque. So at this point, the internal torque will be similar to applied torque, because according to equilibrium condition, the applied torque and internal torque, that means developed torque, will be equal. So at this point, the applied torque is 800 Newton meter. So internal torque will be 800 Newton meter, and that will be positive. So it is indicated here, that is 800 and if you come anywhere in this segment, the internal torque will be similar to 800, because if you come here, then you will see that the applied torque is 800, so the internal torque will be 800. So if you come another point in this segment, similarly, as the applied torque is for 800, the internal torque will be 800. So in this segment, so from this point up to this point, there is no additional applied torque except this torque. So in this segment, the internal torque will be 800. That's why this line has gone along the x-axis, that is horizontal direction. So up to this point, the internal torque will be 800. And then if you just cross this point, then you will face this uniform distributed torque. Okay, uniformly distributed torque. So if you reach this point, if you reach from this point to that point, then you will face additional applied torque, and that is 404 kilonewton meter per meter. That means in 1 meter, the total applied torque is 4 kilonewton meter. So the total length from this point to that point is 0.5 meter. So the total applied torque in this segment will be 2 kilonewton meter. Because this amount of torque is applied in 1 meter, but the segment is 0.5, that means half meter. So in this segment, the total applied torque will be 2 kilonewton meter. So if we convert it into Newton meter, because as it is a Newton meter, so the total applied torque will be 2000 kilonewton, and according to thumb rule, this torque is negative torque. So if you reach this, if you reach at this point, so that you will face this applied torque and this applied torque, and this one is positive, and this total torque is negative. So the resultant torque will be minus negative 2000, positive 800. So at this point, the resultant torque will be negative 1200. That's why at this point the resultant torque is negative 1200. Okay, and as the variation of the applied torque is uniformly distributed along this segment, so the variation of the internal torque from this segment to that segment will be indicated by the straight line. If we join this point and that point by a straight line, so the ordinate of this straight line will indicate the resultant internal torque at that location in this segment. Okay, so from here you will get two triangles, one triangle here, another triangle here. So this ordinate is 800, this ordinate is 1200, and the distance from this point to that point is 0.5 meter. So by solving these two similar triangle, you can get the value of this length, that will be 0.2 meter. So the distance of this point from the origin will be 0.7 meter. So this point indicates that at the location 0.7 meter from this end, there is no internal torque. That means this segment is torque free. Okay, this segment is torque free. That means this section will not that means no torsional stress will be developed at this location. Okay, then if you cross this point and there is no additional internal torque, so in this segment there will be no variation of the resultant internal torque. Okay, there will be no variation in the resultant internal, because there is no additional applied torque. Okay, there is no additional applied. So at this location, internal torque was 1200. So in this segment, at anywhere, the internal torque will be 1200. That's why this line goes horizontally. Okay, horizontal up to this point. And just before this point, just left of this point, there is no additional applied torque. So just left of this point, the internal torque will be 1200. And if you just reach this point, then you will face this internal torque, applied torque. You will face this applied torque. Okay, so according to thumb rule, this torque is 400, positive 400, and just left of this point, it was negative 1200, and if you just reach this point, then you will face additionally 400 positive 400. So at this point, the total internal torque will be 800, negative 800, because it was negative 1200 and you have faced positive 400. So at this point, the internal torque will be 800. So just this point, this 1200 indicates the just left of this point, and this 800 indicates just right of this point. Okay, just left, just right. So what will be the distance between just left and just right? So basically, it is not possible to determine the distance just left, just right of a point. That's why at the same point, two torsional resistance, internal torsions are showing here. Okay, two internal torsions are shown here. So this one indicates the just left of this point, and this point indicates just right of this point. Okay, and in this segment there is no additional applied torque. So in this segment, the applied torque will be similar to this one. That's why it goes horizontally. That means in this zone, the resulting internal torque is 800. So from this diagram, it is seen that the maximum internal torque is 1200, and it is developed in this zone. So the maximum stress will be developed here. So if we apply the this equation of maximum stress, so this is the maximum internal torque. C is the radius, J is the polar moment of inertia. So C is the half of diameter, and this is the equation of polar moment of inertia. And this maximum stress will be similar to the allowable stress, that is 60 MPa. To convert into Newton meter square, it is multiplied by 10 to the power 6. So from this calculation, we have seen that the diameter of the shaft is 46.7 millimeter. Okay, 46.7 millimeter. So it means that the minimum diameter of the shaft will be this one. If you provide, if the diameter of the shaft is equal to 46.7 millimeter or greater than this one, then the maximum shear stress will not exceed this value. And if the diameter is less than this value, then the maximum shear stress will be greater than this value. In that case, the shaft will be failed. And that is the angle of twist. I have already explained it in the last class. So angle of twist means the relative angle of rotation of one end with respect to other end. So this is a shaft having variable cross section. One end is fixed, another end is free. So according to so Tx. So this shaft may be subjected to a different amount of torque. So the torque will not be constant along the length. So at a location, at a point located at x distance from this point, if the internal torque is T, that is indicated by Tx, because the internal torque is not constant along the length if the shaft is subjected to different amount of applied torque. So that's why it is indicated by Tx. That means T is the internal torque. It depends on the location of the point. And Jx also, as the section is variable, so the J will be different at different locations, and it is designated by Tjx. That means the polar moment of inertia as a function of x, and theta is the angle of rotation or angle of twist of this end with respect to other end. So according to Hooke's law, the equation of shear strain is this one, and we know the equation of shear stress due to torsion is this one. Substitute this equation here. Substitute the variable term here, Tx and Jx. And again, if you substitute here, then the general expression of shear strain will be this one. And if we consider a small segment located at x distance from this support, and if we draw the segment in larger scale, and then we will see two faces. One face is here, another face is behind this face. So we can say this one is front face, and the face behind this face is we can say it is back face. Okay, back face. So the angle of rotation of the front face with respect to the back face is d phi, as the length is very small dx, so the angle of rotation angle of twist will be very small. It can be designated by d phi. And in the previous class we have seen the equation of d phi equals to this one, and substitute the expression equation of gamma in this equation. Then this is the general expression of angle of twist. And if we want to determine the angle of twist of this phase with respect to other phase, then we have to integrate this equation, because in this equation it depends on x length. So we have to integrate this equation from this to that, or from this to that. So it is 0 to L. L is the total length of the shaft. So this is the general expression of the angle of twist. And there are two expressions for some specific cases. If the cross section of the shaft is constant, and if the shaft is subjected to a constant torsional force, then angle of twist will be determined using this equation. But if the section is subjected to different amount of torsion, or the section is the cross section of the shaft is variable at different location, then we will determine the angle of twist for each segment. And if we sum the angle of twist of all segment, then we will get the total angle of rotation from one end to other end. And it is explained by this problem. Actually, it is a solid shaft. One end of the shaft is A to E. At E, the shaft is fixed to a support, and there is another support B, and this B is frictionless. That means if we rotate the shaft, no friction force will be developed at this location, and 3 gears are attached to this shaft. One gear is at A, another one is at C, another one is at D, and 3 torsional force are applied by 3 gears. At A, torsional force is 150, at C 280, at D 40. And there is a tooth P on the gear A. Now we have to determine the total angular displacement of this tooth P, because due to applied torque, either this tooth will be rotated along this direction, along clockwise, anti-clockwise direction, or clockwise direction. So we have to determine the total angular displacement, and the equation of total angular displacement is rho theta. Rho is the radius, or you can say r theta. R is the radius, which is given 100 millimeter. So we have to determine the theta. Theta is nothing but the angle of twist. So to determine the angle of twist, we have seen that there are 3 segments: one A to C, another segment is C to D, another segment is D to E. There are 3 segments. So 3 segments will be subjected to different amount of internal torsion. So you have to apply this equation. So to apply this equation, we have to know the length of each segment, the polar moment of inertia of each segment, and as the shaft is constant along the length, so they will be constant. So only the variable will be the length of each segment and the internal torque. So one length of one segment is 0.4, another one is 0.3, another is 0.5. So we have to determine the internal torque developed in each segment. So in segment AC, the internal torque is 150, because if we cart at anywhere in segment A to C, and if we draw the free body diagram, that will be this, and if we consider the equilibrium condition, then the applied torsional force will be equal to developed internal torque, or developed torsional force or internal torque. So according to thumb rule, this one is positive. So in segment A to C, the internal torque will be resulting internal torque will be positive 150. Similarly, for segment C to D, we have to cart in the segment A to C, and we have to draw the free body diagram. And from this free body diagram, positive internal torque is 150. This one is negative according to thumb rule. So the resultant internal torque will be 130. That will be negative. That's why negative. Again for CD, similar by the similar process, the internal torque in segment D will be negative 170, and we know the equation of angle of twist is TL by JZ, and for segment AC, internal torque is 150 and length is 0.5, and for CD, internal torque is this one, length is this, and for D, internal torque is this, length is this. So from this calculation, we have got the total angle of rotation of gear A of this gear with respect to the support, that is 0.2121 radian. It is negative, and according to thumb rule, we have seen that for this case, if the shaft rotates along the anti-clockwise direction, that is positive. But as the value is negative, that means the this gear will be rotated along clockwise direction by this value, and the total angular displacement will be rho theta. Rho is 100 millimeters, so that is the total angle of rotation. Okay, so that's all. I have completed up to this problem in section A, section B. So I will not move anymore. Sure.
Sir, problem 7A একটু যদি কষ্ট।
হ্যাঁ বলো।
Problem 7A ওই এরপরের স্লাইডটা।
ওকে।
আচ্ছা স্যার, এই যে মানে 150 তো অ্যাপ্লাইডটা তো 150 পজিটিভ, তাইলে ওই যে ডেভেলপটা নেগেটিভ না, ওটা ক্লকওয়াইজ হিসেবে তাহলে
No, not negative. Negative means it is this direction. Okay, you have or we have considered that the internal torque will be along anti-clockwise. Sorry, along clockwise, right? Along clockwise. So if we apply the equilibrium condition, that means applied plus developed will be 0, right? So it will be actually positive 150, and that is negative 150, right? So if we negative 150, sorry, this one will be negative, this one is positive, this one will be negative according to the sign, right? So if we take this term on the right side, so that one will be positive. Understand? So say it is x, right? So it will be actually positive 150 minus x equals to 0.
Yes.
Right? Positive, so equals to 0. That means this sign is correct.
আচ্ছা স্যার, বুঝছি।
This sign is correct. And if you see that the value of this is negative, so it means that this sign will be opposite in the reverse direction. Any other question?
No, sir.
Okay, so no more today, as you have no question. So we can stop the class, right?
আরেকটা কথা ছিল স্যার।
Sure.
স্যার ওই যে ভিডিও স্যার লিংক দিবেন, ওটাতে স্যার সবাই অ্যাক্সেস করতে পারতেছেন স্যার, পারমিশন চাচ্ছে।
আচ্ছা, আমি আসলে ওটা ট্রাই করব যে আবার এটাকে করে আমি রেকর্ডিংটাকে স্টপ করি এখন। আচ্ছা, আমি এটা